Hello citizens and welcome back. In today's video I would like to talk about the commodities and how these can form supply chains and how this knowledge can help us build the dynamic economy. As always, if you like this video, sacrifice a like and a comment to the YouTube algorithm and subscribe for more. And here's a shout out to our amazing patrons for their support of the channel and the Armory. What do I mean by commodity supply chains? Well, I couldn't find a better way to label the process of tracking the life cycle of a commodity from when its raw resources are extracted through being processed to being consumed. Now, why is this important? This process is one of the basic building blocks of an economy, and understanding how commodities are made and used is essential to building a valid simulation. And having an idea of what the flow of goods should be can help with implementation and balancing of the system. This is something that Star Citizen is currently missing, and I think it's possible that CAG never even looked at the planned system in this regard. Let me explain with a simple example. Let's say that we have two trading locations. One is a farming outpost which consumes agricultural supplies and produces food, and the other is a research outpost that consumes the food and produces agricultural supplies. Neither of these locations can produce unless they have enough supplies on their input. This creates a demand for the input supplies. Now, given that the outposts start with some supply of their end product, this demand can be satisfied. Eventually, over time, a balance will be created. This assumes that there are quanta transporting the resources between the two locations. For now, let's ignore the existence of players. We can derive some terms from this that I will use further into the video. Any commodity that is demanded by a location and required to function or produce is called an input. Any commodity that is produced is called an output. Now, how do you express the local state of supply and demand on the level of the outposts and then publish that information to the rest of the system? Well, in the simplest terms, all you need to look at is the available stockpile of inputs and outputs and their desired state. You want your stockpile of inputs to be nearly full because without inputs you can't produce. At the same time, you want your stockpile of outputs to be nearly empty because that means you're making money and you have capacity to make more. You can express this stockpile fullness as a floating point number between -1 and 1, representing the difference between the desired state and the current state of the stockpile, and it can be described as your willingness to buy or sell. In the case of inputs, if the number is negative, it means you're more willing to buy, and if it's positive, it means you're less willing to buy, and vice versa for outputs. You can roughly see how this would work from this spreadsheet that I put together. Now, obviously the driving force of trade, manufacturing, and the economy is the desire for profit, so you have to then express this modifier as a local price of goods. Here comes the first real problem. How do you determine the price? The simple answer is base price and some modifier based on supply and demand. We have the second part of that calculation to an extent, but we will circle back to that later. So where do you get the base price? Well, normally this would be the result of calculating your material and labor costs and adding some overhead for profit. This is somewhat difficult to do in Star Citizen, so let's say that CAG set some arbitrary values as the base price, which is essentially what happened. So that gives us the base price for our calculation. Later on, once the economy is going, you can also use the global average price as the base price, but this has some nasty feedback loop side effects, so we should avoid that. From the above example, we know how to determine the price based on the available stockpile, but this is a very simple example which ignores a couple of things. First, some locations such as mining outposts technically have no primary inputs, meaning since they just dig minerals out of the ground, they are not consuming any resources. However, they have secondary inputs like food, fuel, and tools, so we can ignore this problem for now. But it brings us to the second problem. No location has only one input and one output, and often one output has multiple required inputs. This complicates the end price calculation. At the same time, we currently have locations like the main landing zones that only have inputs and output nothing. However, this is by design as to facilitate trading gameplay at the moment, since there has to be some end consumer for every possible commodity. Later on, I believe it will be possible to buy any excess goods from landing zones and sell them elsewhere, most likely major landing zones in other systems. So we can now extend our economy to multiple trading locations, each with multiple inputs and outputs. This complicates things significantly, but if we maintain the model we established earlier, we will have a set of locations that are capable of publishing their supply and demand to the rest of the system. If left alone, this system will eventually, through its own production, move to a state where both supply and demand are extreme, which will lead to a price difference of commodities across locations. This price difference is the motivation to move these commodities between locations. So how do we do that? This is where the quanta come into play. Quanta are essentially invisible NPCs that the economy simulation of Star Citizen uses to execute actions within the economy. Things like mining, trading, hauling goods, pirate activity, or scanning and prospecting. This wider simulation system is internally known as Quantum. But for this video we will assume that Quanta only haul cargo and trade. I am guessing that there is a set number of trading Quanta in the simulation, and that these are somehow dispersed through the verse or the given region. The assumption is that Quanta have full access to prices of commodities to make decisions on where to go to trade. I believe that this will eventually change when data running and trade data is implemented, but for now let's assume that Quanta have all the information they need. Based on this, they can select the most profitable trading route based on their location and available funds. They might also take the risk of combat and piracy into account. Once the Quanta selects the route in a simple system, this trade will execute instantly. Obviously, this is not very realistic and greatly increases the volume of actions that Quanta can take, which swings the balance away from the players. It also limits the use of probability volumes, so in the actual quantum simulation, Quanta physically move from location to location while executing their tasks. This allows for generating random encounters using probability volumes. However, it introduces a major issue. Given instant trading by Quanta, once a profitable route is identified, it will almost immediately become less profitable after the first Quanta executes their trade. On the other hand, if it has to travel for several minutes, this makes it possible for multiple other Quanta to try and do the same. This may result in Quanta crowding a certain location and ruining the prices or being unable to execute any other trades, which would go directly against their purpose of maintaining balance in the economy. However, this can be addressed with a very simple fix. If each location tracks how many Quanta are headed there for trading, this information can be used in the decision-making process of the Quanta looking to trade. This, in essence, is a measurement of the economical risk of the action as opposed to the combat risk. The same way Quanta have varied degrees of combat risk aversion, they can have varied degrees of economical risk aversion. This information can also be published to the players as a frequency of trades or heat associated with a certain trading location, which may aid them in making their own decisions. So now we have a way of generating and publishing commodity prices and for Quanta to make simple trade runs to interact with the system. Given enough time and the correct setup of commodity supply chains, this system should settle into a stable cycle. But there are some improvements that can be done, like allowing Quanta to make multi-stop trading runs. But that's a more advanced problem which some may see resembles the traveling salesman problem, which is a bit out of scope for this video. At this point we can also introduce player influence, which will show us changes to stockpile and price values of trading locations and thus influence the decisions made by Quanta. So pretty much everything I mentioned up to this point is to some extent implemented. Quantum does currently interact with the verse, but it seems like the impact is very minimal because CIG are still testing it. Moving forward, we can start thinking about multiple star systems. This brings further issues. If Quanta have no limit to how far they can travel to execute tasks, it's possible for all Quanta to leave an area. Now, you could say that this is not an issue, and you would be right, but since Quanta are the main regulating force of the economy, this would essentially mean giving up control. So what should happen instead is that the number of active Quanta in an area is reduced, or their parameters are changed as a response to certain events such as piracy, recession, or dynamic events. But at the same time, to make the dynamic economy truly global, you need Quanta to trade over long distances to connect various systems. You could address this by splitting trader Quanta by the distance they are allowed to travel, meaning you could have some that would stay within one star system and some that would travel across systems but only through major locations. And that for the most part is how you build the dynamic economy of Star Citizen. Keep in mind that this is a very basic explanation and the actual quantum system is very complex. In a future video, I would like to talk about the other types of quanta and how they affect probability volumes in the physical verse. And in some more future videos I would like to delve deeper on some other topics I touched on briefly today. And with that being said, that's all for tonight. What do you think? Should CIG keep the economy simple or build a very accurate and granular simulation? Let me know in the comments. Thank you for watching, fly safe, and I will see you in the verse.